Good day, I'm Maile Madziba. Welcome back to our channel. We continue with our 2017 study guide of our CIR 113 module. Today we're looking at the last example of the study guide, which is example 5.4.4. It says the following two requirements must be met at the same time by the solution of NaCl and CuSo4 in water. The first one is that the first requirement is that it must contain 30% of dissolved solids, and secondly, it must contain 5% of NaCl on a mole basis. Now the question says, what masses of NaCl and CuSo4 must be dissolved in 100 kilograms of water? So the very first requirement says that it must contain 30% of NaCl and CuSo4, which means the solution here needs to have 30% of NaCl and CuSo4, and the second one is that it must contain 5% of NaCl on a mole basis. So as usual, as we move forward attending this question, let's choose a basis. So our basis, we'll choose the 100 kilograms of the water. So it's 100 kilograms of water. So that is our basis. Now that we have 100 kilograms of water, we don't know how much NaCl is there, and we don't know how much CuSo4 is there. So for equation establishing purposes, let's choose NaCl to be X and CuSo4 to be Y. So I'll just write that let X be the mass of NaCl and NaCl. It's NaCl, and Y be the mass of CuSo4. So we have defined this to be X and we have defined this to be Y. So let's say this is Z, and let me just say and Z be the mass of the final solution. So basically this is our final solution. So let that be Z, yeah, for calculation purposes. So now with that said, having a basis and also having this defined this, we're going to use the requirements we have to actually establish equations and solve those equations for X and Y, because the question said what masses of NaCl and CuSo4 must be dissolved in 100 kilograms of water for us to be able to meet these two requirements at the same time. So step one, let's just do the solids balance and establish, I hope it's a perfect word, establish the first equation. So we're going to need a couple of equations. So for us to get the very first equation, we're going to be using the first requirement, that it needs to have 30% of dissolved solids, and yeah, that is actually the solids balance. And with that said, we can just move forward to say solids balance. We are told that this one and this one needs to all them combined need to be 30% of this. So we can just say X plus Y is equals to 0.3 Z. So this one's combined is equals to 0.3 that. So that is actually our first equation. So now going to our step two. It's gonna be a little bit longer, but it's easy. So we're going to calculate the total number of moles of the solution, and for us to get that, we're going to be using X, Y, and also the 100 kilograms of water, which means the number of moles of NaCl are going to be in terms of X, because remember we don't know the mass of X, and number of moles of CuSO4 are going to be in terms of Y, and only the water moles will be straightforward because we know it's 100 kilograms. So let me write it down that calculate the number of moles of NaCl, CuSO4, and water, right? So that is actually our step 2. And with that said, we can just start with our NaCO2 and NaCl. The number of moles of NaCl is equals to, we know that it's actually mass NaCl all over mole mass NaCl. And with that said, we know the mass of NaCl is X. It's actually what we're calculating, so we can just leave it as X all over. The mole mass of NaCl, if you use the periodic table, you know that is gonna be 58.5. So yeah, I'll leave it that way, but it's as usual grams per gram mole, kilomole per kilomole, pound per pound mole. But it doesn't really matter much in this instance, as we're establishing equations. So now when you solve that, it will give you 0.01709x. So now this is actually the number of moles of NaCl in terms of x, which is actually the mass of NaCl. Now remember, in these steps we're actually calculating the number of moles of everything. So we're done with NaCl, we come to CuSO4. So number of moles CuSO4 is equals to Y all over Y, which is actually the mass of CuSO4, and then all over the molar mass of CuSO4. And the molar mass of CuSO4, if you use the periodic table, it will give it's actually 159.5, and when you do that calculation, it gives us 0.00627Y. So this is actually now the moles, the number of moles of CuSO4 in terms of Y. Now we come to the water. So number of moles of H2O is equals to the mass H2O all over the mole mass H2O. The mass of H2O, we know from our basis that it's actually 100. It's 100 kilograms all over. The mole mass of H2O is actually 18, so it's 18 kilograms per kilomole. So with that said, if you use a calculator there, it's gonna give you 5.5555. We can just say 6 here, kilomole. So yeah, just to combine everything, let me just say the number of moles total is equals to the number of moles of X, or rather the number of moles of NaCl, which is 0.01709 X, plus the number of moles of CuSO4 is plus 0.00627Y plus 5.5556. So this is actually the total number of moles of the solution. This is actually the total number of moles of the solution here, because the solution contains both X, Y, and Z. Sorry, X, Y, and 100 kilograms, and the total of it is Z. So with that said, now we've actually done with our step 2. Now we need to go to our step 3. Remember, let me just bring back that. Remember, they say there must be 2 requirements, and we actually used the first requirement of 30% dissolved solids, and we're able to get an equation out of that. Now we need to focus on the second requirement, which means they say it needs to contain 5% of NaCl on a mole basis. So we can, step 3. So in step 3, we're going to be doing an NaCl mole balance and establish our second equation. Do an NaCl mole balance and establish a second equation. So let me just bring back the diagram again. So when you look at it, we know that this solution contains 5% of NaCl mole basis. So what we can easily do is that we can easily just say the number of moles of NaCl equals to 0.05 times the number of moles total. I hope it makes sense. So the number of moles of NaCl is equals to 5% the total number of moles. And we know the number of moles of NaCl, we calculated them to be 0.01709x is equals to 0.05. The total number of moles is here. It's 0.01709x plus 0.00627y plus 5.5556. So this is basically the NaCl mole balance. So with that said, as we continue to actually simplify it, we can just say 0.01709x is equals to, when you multiply the 0.05 by here, just to remove the bracket, it gives us 0.0085545x plus 0.0003135y plus 0.27778. So that is how it is. And then if you simplify further, remember there are like terms here, you could easily take the x this side. So when you bring it that side, you get 0.0162355x, right? It's equals to 0.0003135y plus 0.27778. Let me just add another 7 here, right? And this then becomes our second equation. So with that said, we are done with our step 3, and we're able to establish 2 equations out of the 2 requirements. So with that said, we can actually now go to our step 4. Right? So step 4, we actually, remember, let me just highlight here that with that first equation, we have 2 equations, but we have 3 unknowns, right? Here we have x, y, and z. We have a z here with 3 unknowns. Well, here we do have 2, but remember that for us to solve these 2 equations, we actually need 3 equations because we have 3 unknowns. So with that said, we're going to go for a third equation. So in the step 4, we're going to do the mass balance of the whole system. Do a mass balance of the whole system and establish a third equation, right? So that's exactly what we're going to be doing. So when we bring back the diagram, we know that from the system x plus y plus 100 is equals to z, and that's going to be our third equation. So x plus y plus z, plus 100, x plus y plus 100 is equals to z. So that then becomes our third equation. Now, up to here, we actually are done with up to here we actually are done with our chemical engineering concepts. What's left now, it's actually mathematics. So we'll do just that. Remember, now we have 3 equations and 3 unknowns, and we have properly defined our unknowns in such a way that we will be able to find them. So what's gonna happen now in step 5? Let me take you to step 5. In step 5, we're going to actually be solving x and y. So solve for x and y. Like I said, the chemical engineering is done now. We need to make sure that we look into the mathematics of it so that we can actually get the values of x and y, and that becomes our NaCl and CuSo4. And with that said, we can just use the equation that we have and say substitute 3 into 1, right? Let me just bring back 3 and 1 here. This is actually our third equation. It's an equation of x plus y plus 100 equals to z, or z equals to x plus y plus 100. And this is actually our first equation, x plus y equals to 0.3z. So with that said, when we substitute this 3 into 1, where the z, we're going to be plucking x plus y plus 100. So therefore, x plus y is equals to 0.3. Now here there was z, we substituting that other equation, so it's x plus y plus 100, right? And now simplifying further, it gives us x plus y is equals to 0.3x plus 0.3y plus 30. Therefore, when we simplify further, moving x and y this side, we left with 0.7x plus 0.7y is equals to 30, right? And now when you make x the subject of the formula, it becomes x equals to minus 0.7y goes that side and it changes the sign, so it's 0.7y all over 0.7 plus 30 all over 0.7. I guess it's clearer to see here that we actually moved 0.7y that side and divided by 0.703 just to make sure that x is the subject of the formula. And with that said, if you do a simplification here, you can be left with x as minus y plus 42.85714, right? And we can name this as our fourth equation. So we have solved for y. Now we have x in terms of y, and as we move further, we can just say substitute. Remember, our mission on step 5 is to solve for x and y. So now substitute 4 into 2. Let me just bring back our 2, our equation 2. So this is actually our 4, and where's our 2? Let me just bring back our equation 2. Yeah. This is actually our equation 2, if you remember it. This is actually our equation 2, the equation we got after doing the NaCl mole balance. So this is our equation 2. So we're going to be substituting this x value in terms of y into this equation. So therefore, so it's 0.0162355 into, so where there was the x, now we're going to be plugging this value, minus y plus 42 blah blah blah. So, and that then becomes minus y plus 42.85714 is equals to 0.0003135y plus 0.277778, right? Therefore, minus 0.0162355y plus 0.7 is equals to 0.0003135y plus 0.277778. So I multiply through, and moving for further and simplifying, if you can actually check here, you realize that we have y as we have the y's as like terms, so it can easily bring that one here or bring the other one there. If you simplify it, it will be 0.01654.9y is equals to 0.422222, right? Therefore, y equals to 0.422222 all over 0.016549, right? And now that gives us, if you do the calculation, it gives us a y of 25.5135 kilograms. So now our y is actually 25.5135 kilograms. That means our CuSo4 is actually 25.5135 kilograms. And remember, the question said what masses of NaCl and CuSo4. So we have calculated CuSo4 already. We left with x. Now, with that said, we can just say from 4. Remember, we have x in terms of y, and now we have solved y, so it's nothing big. We can just say from 4, or equation 4, x equals to minus the y. Where there's y, we plug in the value, minus 25.5135 kilograms plus 42.85714 kilograms. And if you do a calculation, it will give you x equals to 17.3436 kilograms. I hope it's clear. 17.34364 kilograms. So with that said, up to here we have actually answered the question completely. So we know that the mass of NaCl that has to be added into the water must be 17.3436 kilograms, and the mass of CuSo4 that needs to be added must be 25.5135 kilograms. So this is actually the end of the question and the end of the example, and the very last example of this study guide. So thank you for your time. From now on, I think I need to find the class tests and the semester tests, and if I succeed in finding them, I'm going to make sure that I also solve them, a couple of them, and then upload them. So thank you for your time, and I hope we'll meet again in our next video.